BNSF Railway owns, operates, and maintains about 4,000 locomotives. Situations occur where a locomotive traction motor will severely overheat, which results in the motor fusing internally and seizing. The output pinion gear, now unable to move, causes the train to stop wherever it is on the tracks, costing time and money. To get the train moving again, a field technician has to come out and cut away the pinion gear, currently by means of an oxyacetylene torch. This involves a technician accessing the gear from under the locomotive and operating in a dangerous confined space, as well as being required to be proficient in the techniques used to cut the gear. This entire procedure can take 30 minutes to 4 hours, creating an inconsistent and an unsafe environment for the field technician. Team 12, advised by Dr. Jeremy Worm, has been tasked with creating a consistent, safe method for removing the pinion drive gear so the locomotive can move again. Our solution involves switching away from the oxyacetylene torch, which can burn only upwards of 3,000 degrees Fahrenheit, to a new thermal lance system which can burn upwards of 10,000 degrees Fahrenheit. This allows for a faster cut time and does not require a special cutting technique. Now, all commercially available thermal lance systems only use one fuel rod or cutting rod and a simple trigger lever to control the flow of oxygen through the thermal lance. Our concept takes the singular lance rod and expands it across the entire width of the gear using multiple rods. During some initial testing, we determined that the lance rod must be touching the material it is cutting in order to cut. With this information, it was determined a push valve system was needed to allow the flow of oxygen through each rod to be individually controlled. This valve works off a series of 4 pilot holes and a series of 4 main jet holes. The pilot holes allow the rod to be ignited and burned at the lowest possible rate. The main jet holes, when exposed, allow full oxygen flow throughout the rod. In the closed ignition or idle position, only the small pilot holes are exposed to the pressurized oxygen chamber, allowing a small flow of oxygen to the cutting rod for ignition and a slow idle burn. When the cutting rods come into contact with the cutting material, the push valve depresses into the manifold until they reach the stop post. This exposes the main jets, allowing more oxygen to flow to the cutting rod through both the pilot jets and the main jets, bringing the cutting rod to maximum temperature and maximum cutting rate. Here you can see how each individual rod can be activated. Based on the cutting scenario, each rod may not need to be cutting while others do. The springs aid in the closure of the valves when the rod has no material to come into contact with, thus bringing the rod back down to a slow idle burn. This new take on a commercially standard cutting rod system allows for all types of expansion for other applications. With an individual passive valve system, the manifold can be modified to cut any length with the addition or subtraction of cutting rods. Our recommended next steps for this project is to work with Senior Design Team 52. Along with their work on the mounting and movement of this manifold, the manufacturing and adjustment of the initial prototype and final prototype will be handled by them as well. The final model will be large enough to cut an 8-inch diameter pinion gear on the locomotive.